In this video, we're going to look at a reaction called the Robinson Annulation. And annulation should trigger the formation of a ring. Whenever you hear that, that's what's happening. So the Robinson annulation is 2 steps, and each step is a reaction that we've just recently learned. So we're going to have a Michael reaction, and that Michael reaction is going to be followed by an intramolecular aldol. So the Michael reaction is going to typically, or in this case, is going to form a 1,5-diketone that can then undergo the intramolecular aldol reaction. And what we're going to form is a 6-membered cyclohexenone. So let's look at an example. First, we need to do the Michael. So we're going to need a donor and an acceptor. So remember, our alpha hydrogen is removed from the enolate. That forms the new bond with the beta carbon of the unsaturated molecule. So remember, we need to have a 1,5-diketone. So 1, 2, 3, 4, 5. Excuse me. I have that 1,5-diketone. The aldol is going to form between carbons 5 here and what I'm going to call 0. So remember, we're forming a 6-membered ring. This is the alpha hydrogen that is going to be removed for the intramolecular aldol reaction. So our 6-membered ring, so we've got carbon 0, 1, 2, 3, 4, and 5. Carbon 1 is going to keep its carbonyl. Carbon 4 is going to keep the ester. And then carbon 5 is what has the new bond to carbon 0, and that is what will be the double bond, because we are going through the dehydration step. So there is your Robinson annulation product for this example. Let's look at another example. So there's our Michael. Tones. So we can do that right. My new bond is between 1 and 6. That is going to be the double bond. Carbon 5 has a methyl group, and it also has the rest of the ring. So this is actually a fused ring, and I just made that to 4, which is not the case. It's between 5 and 6. So let's undo that here. So our 5-membered ring is here, and put my methyl group out this direction. And then our other carbonyl is on carbon 2. And then we also have the carbonyl here on the ring. So here is your final product. We've got our new 6-membered ring. It happens to be bicyclic because our starting material also contained a ring. One more example where we're going to work backwards. We're going to be given a product, and we're going to decide what's our reactant towards this. Now I know what I'm going to be doing is making a new bond. Carbonyl in the previous step. The dicarbonyl for the Michael is here. So this is the location of the alpha hydrogen, which means this is the new bond that is formed. So now I'm going to break that into 2 pieces. And that means this other hash was the alpha beta unsaturated, so there was a double bond there. So here are the original Michael donor and acceptors that